So this is lesson 1.3, measuring segments. So what we hope to accomplish is to be able to find the distance between 2 points, find the length of a segment, when to use equal and the congruent symbols, and midpoint. Okay, we're going to start off with looking at this fish. As you can see, the end of the ruler is rubbed off, and I can only keep my fish if it's a certain length long. So how am I going to do that? Well, I can pick my fish up and I can move it to the portion of the ruler that's still visible. So if my fish is 17 to 27, how long is it? Well, I can count the tick marks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or I can say 27 minus 17 is 10. So that's one way of doing that. So we're not going to bother with finding the actual length of the fish. We are going to move on. So Postulate 1.5 says that every point on a line can be paired with a real number. So you'll notice that they have a ruler below. So point A corresponds with a coordinate lowercase a. Point B corresponds to the coordinate lowercase b. So the distance between points A and point B is the absolute value of A minus B, because distance can never be negative. When I drive to work, I drive 20 miles. When I drive home, I drive 20 miles. Because I'm going backwards, it doesn't change the fact that the distance is positive. So let's take a look with some real numbers. What is ST? So S and T. Notice that it doesn't say what is segment ST. So it's not asking me about segment ST, it's asking me about ST. The notation is really important because whenever you don't have the segment symbol, it's talking about length. So I'm going to say, so ST is equal to the absolute value. What's my coordinate of S? It's -4, minus my coordinate of T, which is 8. Close the absolute value bars. What's -4 minus 8? So that's equal to the absolute value of -12. And the absolute value of -12 is +12. So ST is equal to 12. Postulate 1.6, the segment addition postulate. If 3 points, points A, point B, and point C, are collinear, meaning they are on the same line, and B is in between A and C, then then AB plus BC is equal to AC. So what we're doing is just adding up these little parts. So if this is 5 and this is 10, then the whole thing is 15. So let's put that in action. If EG is 59, so it's telling me that this whole length is 59. What are EF and FG? So all I need to do is add EF, which is 8x minus 14, plus FG, which is 4x plus 1, Now when I add that up, what does it equal? That's right, it equals 59. So now I'm going to combine my like terms. 8x plus 4x is 12x. Negative 14 plus 1 is negative 13. And all of that's equal to 59. So I need to isolate my variable. So who's in the way? 13's in the way. So I'm going to add 13 to both sides. So now I have 12x is equal to 59 plus 13, which is 72. So now I have to divide both sides by 12. So x is equal to 6. Am I finished? No, I am not. So now I want to find EF. So EF is 8x minus 14. I'm going to plug in my 6. So I have 8 times 6 minus 14. 6 times 8 is 48. Minus 14. So EF is equal to 34. Notice again my notation. I don't say segment EF is equal to 34. So you only use the letters when you're talking about length. So let's find FG. So 4x plus 1. 4 times 6 plus 1. It's 24 plus 1. So FG is equal to 25. Now what I would like for you to do with this one is to pause it. So pause it for as long as it takes for you to work it, and then I'll have the answer. Okay, so here's what we did. We said 4x plus 6 plus 7x plus 15 is equal to 120. Then we combined our like terms. So we ended up with 11x equals 99. We solved for x. X equals to 9. X is equal to 9. So the next thing we do, because we're not finished yet, we want to find out the value of jk. So we get the 9 and we plug it into 4x plus 6. So jk is equal to 42. And then we did the same thing with kl. So we knew that kl was equal to 7x plus 15. We plug in the 9. And then we have KL is equal to 78. So this is really important. When numerical expressions have the same value, we say that they are equal. When two segments have the same length, then the segments are congruent. So whenever we're talking about numerical values like AB in this case equals 1, so whenever we're talking about the length or numbers, we're going to use the equal sign. So numbers is equal. When we're talking about the line segment or a diagram, then that is congruent. And it's a little wave over an equal sign. So this says AB is equal to CD. And we can tell that because AB is equal to 1 and CD is also equal to 1. This little tick mark right here says that they're congruent. So you don't always have to have a number value to let you know that something is equal. So segment AB is congruent to segment CD. So remember, whenever we're talking about the parts of the diagram, we use congruent, and we also use the appropriate notation. Whenever we're talking about length or a number value, we use the equal sign. Also notice that it does not have the line over it to talk about the segment. Okay, so now we're going to compare segment lengths. So whenever you see AC, when they ask you what AC is, you know that they're talking about a number. So what's my value for A? So I'm going to take the absolute value of -2, which is my A coordinate. C is 5 minus 5. So that's going to be the absolute value of -7. So I know that AC is equal to 7. Now let's take a look at BD. So B, I'm going to take the absolute value. Looks like that's around 0.3. And D is at 10. So 3 minus 10 gives me the absolute value of -7, which is 7. So BD is equal to 7, AC is equal to 7. So to write this out, I would say segment AC is congruent to segment BD, which means that AC is equal to BD. Let's try this one. So we want to know if we want to know if segment AB is congruent to segment DE. So let's find AB. So AB is equal to absolute value of -2 minus 3. So absolute value of -5. So AB is equal to 5. So now let's take a look at segment DE. DE is equal to the absolute value of 10 minus 14, which gives me the absolute value of -4. So DE is equal to 4. Are those congruent? No, they are not. So we can say that segment AB is not congruent to segment DE. Okay, we're going to talk about some more terminology. So a midpoint of a segment is a point that divides the segment into two congruent segments. The notation for this could be like the tick marks say that segment AB is congruent to segment BC. I look at those marks. I don't have to have a number, and I can know those are the same. So on this rectangle over here, if I have 2 tick marks on this line, I know that the segments are equal. And sometimes there's more than one, so you denote that by the number of tick marks. So the 1 marks go together and the 2 marks go together. So that's another way to tell. So the point, ray, or other segment that intersects the segment at its midpoint is said to bisect the segment. And the line, ray, or point is called the segment bisector. So B is the midpoint of segment AC. Line L is a segment bisector of segment AC. So now let's use the midpoint. Q is the midpoint of segment PR. So what does that tell me about segment PQ and segment QR? That tells me that they're equal. So I can say that 6x minus 7 is equal to 5x plus 1 because I know these two segments are equal. Now I'm going to combine my like terms. So I'm going to subtract 5x from this side. And what I do to one side, I have to do to the other. So x, let me add 7 over here, is equal to 8. So now, what do I need to do? Well, I need to find PQ and QR, and in turn, I also need to find PR. So let's find QR first. I like the way these numbers look. I think it'll be easier to work with. So QR is equal to 5 times 8 plus 1. What's 5 times 8? That's 40 plus 1. So that's QR is equal to 41. So now let's find PQ. So PQ is equal to 6x minus 7. PQ is equal to 6 times 8 minus 7. So it's 48 minus 7 equals 41. So this is a good way to check. I didn't have to do all of this work if I was confident in my QR, my segment QR. Now what is PR? So PR, I just add these two together. So I get 82. And that's all there is.